Longest substring without repeating characters. Okay, given a string S, find the length of the longest substring without repeating characters. Okay, so essentially, if we're given the string, say, ABC, A, B, C, B, B, I might zoom in here. ABC, if we're given the string ABC, A, B, C, B, B, the answer should be 3 because the longest substring would be ABC, which is here. Okay. If we're given, 4 Bs, the answer would be 1 because there's only, one character, so the longest substring with unique characters would be 1. Now, when we're looking at the first two examples, a trivial way to do this, right, is basically you could think, oh, we just need to calculate the number of unique characters, and that's our answer, right? Because in this string, there's 3 unique characters, so therefore the answer is 3. And in this string, there's only 1 unique character, so the answer is 1. And then it's like, if you thought, oh, the simple way to implement this in code would just to be to create a hash map. And to explain what a hash map is, it's basically a data structure that has key value pairs. So basically, let's say I input into my hash map, the value A as my key, and I set the value to 1. What that basically means is if I query my hash map with the value A, it will return me the value 1. So you can use like letters and strings as keys, and you'll return a value. Whereas, like, say, an array, it's all based on an index, which is an integer. So you give it a number, and it will return the element at that index. So hash map has key value pairs. So obviously, in a trivial example, if I wanted to just calculate the number of unique characters, I could just say, store it as a key, and then query the hash map to see, like, oh, does the letter A exist? Does the letter B exist? Does the letter C exist? And then obviously the answer would be the number of keys in the hash map, because that would be the unique, the length of the keys. You basically ask, you return the keys as a list, or the number of values even, and then you just say, okay, what's the length of the values list that you return from your hash map, and that would be your answer. Now that would be nice, but that was actually, in fact, that's why they give you example 3 here, because they give you the string. So I'll tell you why that's wrong, because they give you the string PWWKEW, and you think like, oh, 4 unique characters, the answer should be 4, but the answer is 3 because the order matters, because the longest substring is WKE. Because finding all the unique characters, and that would be the answer, would be a subsequence, not a substring, which they explain here. Okay, so how do we find the substring? So I'm going to use a different example to explain this. So let's pretend that we had DVD W is our string. So we've got to think about, like, what information do we need to solve this? So one piece is that we do need to know the number of unique characters. So we need to keep track of that. And so probably the best way to do that would be a hash map, right? Because we can store each unique character as a key in our hash map. So that's how we can solve that problem. The second thing we need to know is obviously some sort of a variable that will store a number, which will be the maximum length of the substrings, right? So there's going to be a bunch of substrings, one or more substrings in the string we're given, and we need to basically find the maximum. So we have to store the maximum integer value. So we need to know that. So that's the second thing we need to know. So that won't be included in the hash map. And the third thing we need to know is as we're progressing through our string, so the best way to do this would be to obviously navigate the string as through a loop, like a for loop, and start from the 0th index and move our way through the string. So if we were to take that approach, we would want to know if we encounter a duplicate letter, then we need to know where we can kind of reset to. And what I mean by this is that if we look at this string example, say we add D to our hash map, we add V to our hash map, and then we encounter a second D, a duplicate D, that basically means, okay, the maximum substring here would be 2, which is the DV, right? Now obviously, we can't just keep going and just say, okay, let's look at DW, because that would be 2, because actually we need to reset to a certain point or recalculate the longest based off the V. So it'd be VDW, because the answer would be 3. So we need to wait to basically store previous results, basically. So we need to store the index of, we need to basically store the index of of the first point of the current substring, basically. So those are the 3 pieces of data we need to know. Actually, there's one more. The last one we need to know is not only do we need to store the current the current starting index of the substring, we need to also store the where to start that substring if we do find a duplicate. In this case, if we looked at the D, we'd need to know the index of V, so we can start there, right, at the start of a new substring. Okay, so so what we're going to do is, since we store the key, we're storing each unique character as a key. What we can do is actually store the index of the next character as the value. So in this case, if we had in a hash map the key D, we'd want to store the value 1, which is the index of the potential next start of a substring if we happen to find a duplicate D. And in this case, we did. Okay, so so to put it all together, we're going to need a hash map. We're going to need a variable integer to store. We call it answer, which is going to be the output, which is the longest substring, which we're going to have to constantly update based on new substrings we find. We're going to need to store the current starting point of the current substring, so we'll just call this J. And we're going to need to store the value, so the key would be the characters of our hash map, and the associated value, would be the index of the next character. So the index of the next character, in the case that we find a duplicate and we have to reset. And then obviously we'd have an I, because we need to have an index to iterate over the original string. Okay. Now, so that's the kind of all the data we need to know. So when we actually the thing about the calculation for answer, it will basically be we want to know that the current length of the substring would be I. So let's say if I was pointing here, so to 1, and J is pointing to 0, we'd want the length to be I minus j plus 1, because that would be, d and v, which would be the value 2, which would be the value of the current substring. And we want to set that to answer, to equal the answer. Now, when we get to, say, d, this duplicate d, we obviously update j to point to the v. And we don't need to actually update I. We can just keep I here. So we keep I there, and then we can recalculate the length of this substring. So in this case, it's still 2. And then we update I to point to W. And then we recalculate J, and obviously J is 3 now, and that would be our answer because we've reached the end. And obviously we'd update the value while we're pointing at this D, and we update the value of the D key to point to W. In the case we found another D or another duplicate D, we could do the same thing over and over again. So that is the logic. So to break it down, we read the question, the problem statement. We made sure we understood the problem statement, and then we thought about some example strings. And we examined like what data do we need, what data structures do we need, what data do we need, and then we thought how to calculate the answer just on a whiteboard. And now we're going to go ahead and execute this into the code. So we're going to clear the board here, and we're going to write some code. So start off. So we're going to just go ahead and create a hash map. Just call hash map. Now, note in Python they call them dictionaries, but we'll just use hash map. So you want to say the answer equals 0 by default. We're going to say n equals the length of the string that we're given. We're going to set I to 0 or ij to 0, 0. I'm going to say while I is less than n. Now, so the first thing we're going to do is we're going to say, okay, does the character we're looking at exist in the hash map? So we're going to say if si, which is the current character, is in our hash map. If it is in the hash map, basically we want to update the j to be the starting position of our new substring, because we want to update we're starting from a new starting position for the substring. Now, when we're starting this new position, now there might be a scenario where we encounter a duplicate, but the duplicate is actually pointing to something that is, so j, let's say we have a string like so there might be a scenario where j is, so we find a duplicate. So let's say we have a string like So so before we calculate J, if we find a duplicate, we have to think about the scenario where what if there's multiple duplicates. So let's say, we've got our hash map. So we've got the hash, and the hash map's we've got A in our hash map, and it's pointing to, 1, which is the B, and then we have B, which is pointing to 2, and then we find C, which is pointing to just pointing to 3. And then we encounter the first duplicate, which is the second C. And then obviously what we want to do is update J. So let's say J was pointing to the A, and then we find this C, and there's a duplicate here. We update J to be this C, right? This is the new start of this new substring. Now, if we iterate to the A and we find a duplicate, then obviously we look at, do we want to update the J to point to the B, basically? And the answer is no, because obviously we've already assessed this first substring to be, length 3. So we don't actually want to reset the J to before that, right? Because that could cause a lot of problems. So we only want to reset to the value stored in the hash map if it's basically greater than what the current value of J is, right? Not if it's less than, because if it's less than, it's like it's in a previous substring which we don't care about. So for this line on line 15, we actually want to find the maximum. So you can use the max function, and you can say max d. So let's think about this. So we want the value. We want to input a key into our hash map. And get the value, which is the index we want. So we'll say the hash map, and we'll say we'll pass into the hash map our key, which is the current character, and then we're going to compare that to the current J. Good. Okay, so moving on. So after this, we want to reevaluate the answer, because we've incremented a character. So we'll say the answer equals the maximum between the. So if you think about this, we want to evaluate. So as we're incremented to a new character, we want to reevaluate the current answer, which is the longest substring. So what we want to do is compare the current answer to the I and the J, which we mentioned before. So how we write this is max, the current answer, because we want to know the maximum, and the current substring we're on. So it'd be I minus the J plus 1. Because as I showed before, this would be the current length of the substring. Okay, so then we want to do we want to update the so if it's a new character, we want to add it to our hash map, and if it's a duplicate character, we want to update that current character's what it's pointing to, the value that it's pointing to, the index. So all we have to do is go grab the hash map and go whatever character we're looking at, the current character, let's just update that value of that key to be I plus 1. And as I said, the reason it's I plus 1 is because we don't want the we want to, if we do find a duplicate, we want to go to the next index of the previous duplicate. So in this case, if it was, ABA, ABAC or something, right? If we get to the second A, we want to update the value of the key A to point to B, right? Instead of we want it to point here. We want to point here, and update our j to that, and then sorry. So if we have the string ABAC, we're going to update our j to point to the B, which is not the A, the original A, not this one, and then we want to update the value of the A key to point to C. So, okay. All right. Then, obviously, we need to increment the I and go ahead and return the answer, and we are done. So, if we clear everything, we zoom out a bit and submit this. Of course, lens, it's len. Yep, so there you go. It is a success. And that is how you find the longest substring.